Hi, welcome to the video tutorial for Let's Think Secondary Science 15, which we've called How Many Are There? And from my own background as a biologist, this is one of my favourite activities. And I have always linked this activity to the debate in India over censusing tiger populations. If you Google tiger censuses, if that's the right way to say it, in India, you will find there's been a massive debate over how they estimate tiger populations. So the illustration we use here to get the students talking, and that we'll come back to, is an image of a tiger, an image of a whale. And many students, I know my own children, are really familiar with this image where Gordon Buchanan and other famous naturalists and scientists have gone to an unexplored area of Burma or a volcano and tried to find out what animals are there. Because in the 90s, there was a debate in India over the fact that they felt they were overestimating the numbers of tigers in reserves because they were using the pug marks. But actually, one scientist found that photographing and rephotographing, that was a better way of getting a real sense of how many tigers are in the population. So really, this is just a version of mark recapture that has always been done in biology, but brought up to date and made as current and as relevant as you can. The activity in itself starts with a focus on woodlice on the floor, and this was a problem in my house, and we'd have loads of woodlice, and my children would say, well, how many woodlice are there, Dad? And so in this lesson we're focusing on proportionality, we're focusing on probability, and we're focusing on sample. Proportionality because we're comparing the ratio of two variables expressed as fractions. Probability because really all numbers we're using are a matter of chance, and sampling because how we're choosing part to represent a whole to make a prediction depends on chance and the size of the sample that you take. What the students actually do is use coloured beads to represent woodlice. So you'll need to buy, well, it says on the Technic video, you need to buy lots of these. So the idea is that we have a sample of woodlice, and there are lots of them. We don't know how many there are. So what the students do is they take out a handful and count them. Okay, so here I've taken out 2, 4, 6, 8, 10, 12, 14. I've taken out 16. What I then need to do is put in 16 of a different colour. 2, 4, 6, 8, 10, 11, 12, okay, so I need to put in 16 of a different colour, and it's much better to use bags than beakers. So population that's mixed about, and it's good because it's visual and they can see that there is a proportion of the beads that are now black. So what the students then do is they take out another handful and they count the total number, okay, but also how many are black. And the idea is that the ratio of this is the same as the ratio of the beads at the beginning. So really we're dealing with 4 numbers. We've got the total population, which we don't know, which is unknown. We've got the first sample that it took out, which for our case was 16. And then we've got the second sample which we took out, which here is 25. And if you have a look, this represents it quite well. If you have a look down here, we've got the population with the marked ones mixed in as a proportion. And now we've taken a sample with the same proportion in. So we've got 1 out of 25 of these are black, so it's a 25th. The population is 25 times bigger than this number, and then how can the students use these numbers to work this out? So in effect, this number is 25 times bigger than that. So what they need to do is somehow use these numbers. And again, with all of the Let's Think Secondary Science lessons with maths, the numbers need teasing out from the students. They need to share their ideas and listen to their peers. The key insights come from their friends, not from me. because my language is too sophisticated. My understanding of probability, ratio, equivalent fractions, I'm using all of the time. We need them to develop their understanding by sharing how we can work out the population, because they've got to feel that there's something going on, because they can see the proportions. There's some black ones in here, and there's one black one there, or it could have been two. So what we need to give them time to do is, as a group, pairs, fours, whatever, come up with a way of describing what's happening with the numbers. So you've got this population is 25 times bigger, so this population should be 25 times bigger. So what is the estimate for the population? And once they've had a go at estimating it, they can then count the total number and see if they're correct and discuss that with you. And someone in your class will come up with a good way of describing this, because their numbers will work better than mine. It might be 10 to 30, so it might be 3 times bigger. So this is the beauty of it, because there's lots of variation. We're dealing with living things, so that's why we need to talk about correlation, we need to talk about probability, we need to talk about ratio, and that might be as far as you get. There is a closing activity. I mean, the slide, the sheet itself should help some of the students because they can see that. Okay? So the card will lead some of them through it if you need to, or you could just put that on as a PowerPoint. What we then can move on to is a real life situation of how people estimate populations of sea mammals, where they use marks on whales. And they can use that to do a mark, recapture, photo, re-photo, see, re-seen. And this is how they actually estimate populations of animals that they can't actually see. So you can then use this to revisit the example at the start to get them to articulate how you'd apply this understanding, or even in a real problem that biologists face, or even give them the information about the tiger census problems in India and let them read it and let them see what they think and see how the thinking they've been doing is applied to the real world.